Hello everyone. Today we're going to start a new chapter, chapter number 5. As we said, in chapter number 4, we have learned many techniques to convert the amount of cash flow at some specific point to another time point. We can convert the present value to its equivalent future value, and we can also convert the future value back to its present value. We can also distribute this present value or the future value to a same amount of annuities for every year along the timeline. Okay, and we have also learned how to convert multiple cash flows on the same timeline to a single equivalent cash flow. Okay, either at present or in the future or for every year. And we said that's gonna be the technique we're going to use in chapter 5 when we want to evaluate a single project. Okay, so so chapter 5 is just an application of the cash flow conversion in chapter 4 on real cases. Before we dive into the chapter 5, we need to announce the homework number 3. So it is available now, and then the due date is on October 26th. The time is the midnight. Okay, and the rule is the same as the previous 2 homeworks. So just do the homework on Canvas, and then you can submit several times, and your highest score will be recorded. Okay, but try to finish that before the due date. Also, we're going to have test number 2. It's gonna be on November the 2nd. Okay, that's the plan, and it's scheduled in the syllabus, so you can go check the time. And then the rule is the same as the first test, so you're gonna have like 24 hours window of that day, the day of November 2nd, and then you only have one chance to submit your answer. Okay, and of course it's not proctored, and you can use your textbook, your notes, your slides, okay, your scratch papers and the calculators, okay, and so the rules are the same as the first test. All right, so now let's start the chapter 5. So chapter 5 is to evaluate a single project. Here is an example. Okay, so this nice car, very shiny, very, very, very beautiful, right? So this is a car, a model that is, I think it's from Ford, okay? So that is built by the new material called carbon fibers. Okay, if you are a car fan, you might know this new material. It's been developed on the market for a while, but there is a debate, okay, because we all know that it is lightweight and it's high strength, which means if you use the carbon fibers to make a car, the weight of that car is gonna be much lighter than the car that is made of the normal metal. Okay, the normal metal. So if the car is lighter, that will save the fuel consumption for that car, right? So it is proved that this new material can save 20% to 30% of fuel consumption each year for a car. But another side of this new material is it is very expensive compared to the normal metal material. Okay, so the cost of it is 15 to 20 per pound. Well, so it has two sides. One side is it's very energy saving. Another side is it's costly. So the industry is still having this debate of do we start to change or move on to use this new material for all the future cars, or do we still stuck with the normal metal material? So your question for this to answer is how much more they cost, the materials cost for a car versus how much more a car made of this can save. So you want to compare this. If you save more, okay, then it's a good deal. If you save less than what it costs, then this is not an acceptable proposal. Okay, so how do you know? How do you compare these two? How do you determine if this is a smart trade-off or not? So this is what we're going to learn for this chapter. This is only one project, okay? So this project is about to use a new material to build a car. And you will know the cash flows, the cost of this new material, the savings of this new material every year, and maybe at the end of the use, you can sell it at a price. So all these cash flows, does it make sense? Does it save you a lot of money? Or what you have paid for the car is over than what you can save every year? Okay, so that is your single project problem, and you want to find a way to evaluate if it's acceptable or not. All right, so here is the summary of this chapter, or we can say it's the motivation of the chapter. So all engineering economy studies of capital projects. Capital projects means you want to invest some amount at the beginning. Right? Like you need to pay for an equipment, you need to pay for some material, you need to at the beginning, at the time zero, you need to spend some money so that you can initiate this proposal. So that's the capital investment. And that type of investment or project, we call it capital projects. Okay? So all engineering economy studies of capital projects should consider the return that a given project will or should produce. So if you want to invest some money at the beginning, you are expecting to have receivings in the long run, in the future time, every year or maybe every month, right? And those receivings should be at least equal to the money you have put into the project at the beginning. That's what we call recover. Okay, so you want to consider if the return, the receivings can cover what you have spent at the beginning. That's the question for every engineering economy study. So so the basic question is whether a project, an investment, and all the expenditures along the timeline, whether they can be recovered by revenue or savings over time. Okay? In addition to a return on the capital that is sufficiently attractive in view of the risk involved and the potential alternative uses. So, when you make a decision, your objective is to evaluate the return of a single project to see if that return can cover several things. Okay, so the first thing is if it can cover the capital investment. Okay, and second, if they can cover the associated expenditures Like every year you need to spend some money to maintain your equipment or to fix it, repair it, okay, or operate it. And those are the expenditures you need to consider, and they need to be covered or to be recovered, okay? And third, the risks involved. Well, if you invest in this business, it is possible that the business could go wrong. It could be because the market is not healthy, okay? It could be because you hired a wrong person. Well, those risks are something you need to take. And you want the profit of that project can somehow recover this risk, okay? So that's the third thing you want to recover. And the fourth, the potential alternative use of other opportunities. That's the opportunity cost. So besides the capital investment, the associated expenditures, and the risks, you also want to be satisfied by this project because you invested the money into this project, which means you couldn't invest the same amount of money in another maybe better project. So what is gone with you not using the other project is the opportunity cost you also want to recover. Okay, so if you invest in one project, you want to have something payback, you want to have return, and you ideally you want the return to cover all of this stuff so that you will be satisfied, so that the project will be justified. Okay, so this is all about this chapter. You want to evaluate if a single project can recover all of this summed up together. If yes, then that's a good project. You will give it a green light. If no, then you will reject that project and look for another better option. So the contents of chapter 5, you are going to learn 5 different methods that you can use to evaluate if the economic profitability of a single project is good or not. Okay, so the 5 methods, they are present worth method, future worth method, annual worth method, and these 3 methods, they are just to use the methods we have learned in chapter 4. You convert everything to either present or to the future or to every year, and then you wanna compare if that value is bigger or equal to 0. Okay, but the tricky part is if you want to do the conversion, you will involve interest rate. Okay, and in this single problem evaluation, the interest rate is gonna be something called minimum attractive rate of return. So MARR, that's gonna be your interest rate for the timeline. Okay, so MARR is an interest rate. We will explain the MARR later, okay? And I will let you know how do you decide what is the MARR. But you just need to know when you do the conversion using the present worth, future worth, annual worth methods, you convert the cash flow at the MARR, okay? Right, and then you will have your equivalent present value. You compare that with 0, and if it's bigger or equal to 0, then you say this is a good project. You accept that. If not, then you say you're gonna reject that project. Okay, same for the future worth method annual worth method. You always compare that with 0. Another two methods is called internal rate of return and external rate of return. Okay, so these two methods, the goal is to calculate some interest rate. Okay, so you're going to calculate an interest rate and compare that with your MARR. Okay, you want to see if it's higher than your MARR or lower. If it's higher or equal, then you will say this is a good project, because MARR is really your bottom line. It's the interest rate. So you will say my interest rate is, my ideal interest rate, MARR, is 10%. Okay, so any project which can return me interest rate higher than 10% or equal to it, I will say yes. And so that's why you want to compare the calculated I% with your MARR, right? Because that's your minimum attractive rate of return. That's your bottom line. All right, so these are the 5 methods you're going to learn. And then in chapter 6, you are going to use these methods for evaluating the economic profitability of multiple projects. So you're gonna have multiple options, and then you're gonna, convert all of these options back to a present worth or a future worth or annual worth or some interest rate, and then you can compare apples to apples. Okay, so that's the contents of chapter 5, and that's why we learn this method, because we're going to use them in chapter 6. All right, now back to this MARR. Because MARR is important in the chapter, right? It's gonna be your interest rate. So how do you determine the MARR? Well, there are many ways to determine that. Usually for a big company, they will have their own team made of, managers and experienced leaders and accountants, financial, FEO, right? Those head persons, they will sit together and then look at their, financial report and the market. They can decide their MARR. Okay, that's one way. And another way is you just go check the market and see in the same business, in the same industry, how is the average interest rate, how is other similar companies' return, and you want to compare that with your own situation, and then you can make that decision like, okay, if averagely everybody is earning like 5%, then I would say 5% is my bottom line as well. So I will use that as my MARR. Okay. And also, here is another way that you can determine MARR. For example, if your company has many ways to improve its profitability, so you have this many proposals, okay, from A to G. So proposal A is you can upgrade your computer network so that everything can be more efficient, okay? That will improve your efficiency, so that you will have more, revenue. And another option B is you can have new delivery trucks, so that will improve your delivery speed, and then your logistic cost is gonna be lower, right? That is also helpful for your profitability. And option C, maybe you can remodel the loading docks. It also helps to increase your logistics speed. And option D is you can hire in-house data entry, okay, so that your inventory record is made more efficiently. Proposal E is you can purchase accounting software, so you don't have to hire expensive accountants to help with some simple accounting tasks. So that will lower your cost. And option proposal F is you might provide new laptops to salespeople so they can, when they do sales, they can be more efficient, right? And more effective. And the last proposal is you can install security cameras in warehouse so that you can make sure your inventory are safe, and you can reduce the staff you're using to safeguard your inventory. So that's another way to lower the cost. All right, so imagine that your company has all these potential opportunities, but you want to decide which ones to go with. Okay, so every single of them will cost some money. Okay, you want to upgrade your computer network, of course you have to pay for that. You want to have a new delivery truck, yes, you need to pay for that. So everyone, you need to know how much it costs, and also you want to know what is the return on that investment. Okay, so imagine that we already know how much they cost. Maybe for option A it costs 60,000. Okay, and then the return of it is maybe the return is 35%. So which means if you invest 60,000 to upgrade your computer network, then your profit would be 60,000 times that return rate. Okay, so this is gonna be your profit. So imagine that you know this information for every single project. Okay, I won't write all of them down here to just save some time, but you can imagine as a company, you should know all the cost and the return and the profit for each proposal. Okay. And then the next question is, okay, you don't have that much money now. Then you need to go to the bank. You want to borrow some money from the bank so that you can implement all this or some of these profitable proposals. Okay, so what information you will get from a bank? The bank would say, okay, if you borrow some money, you need to pay some interest. That makes sense, right? And the more you can borrow, the higher interest it could be, because the risk is high that maybe you couldn't repay the bank. So the bank needs a higher interest rate. And then the bank might just evaluate your ability, your company size, and say, hey, the maximum amount I can lend you the money is maybe just 600,000. Okay, so that's the information you can get from the bank. Then how do you decide which project to go with? So we can make a chart to do that, to make that decision. And that will show you what is the MARR is. Okay, so the chart could be the x-axis is how much you borrow from the bank. Okay, and the bank said the maximum amount is 600,000 maybe, right? So you might have, you can borrow first 100,000. I will say 100K, okay, to save some space, and then 200K, and then 300K, and then 400K, and then 500K, and then 600K, and then, well, they don't want to lend you 700K, but we still can draw it on this chart. Okay, so and then we can use this y-axis as the interest rate that you need to pay to the bank. Okay, and so the bank said, if I lend you 100K, the interest rate is 10%. So that's your point. And then the bank said, if you want to borrow less than 200K, still it's gonna be 10%. But if you want to borrow more, like over 200K but less than 300K, the interest rate is a little bit higher. Maybe 12%. Okay, so let's label this intervals in advance so that we know where we are. Okay, and then so the bank said, if you borrow over 300K but lower than 400K, your interest rate could be something like 14%. Okay, and if you borrow over 400K but lower than 500K, then your interest rate could be 15%. Okay, and if you borrow over than 500K but lower than 600K, your interest rate will be higher than 15%. Maybe it's 17 or 18% over there. Okay, so you can draw a line crossing all of these points so that you can have a curve of how much you borrow and how much percent you need to pay to the bank. Okay, and the next thing is you can draw the project. You can draw the project and its profit on the same chart as well. So what it means is you have project A, you remember that? And the cost we said for project A, cost is 60K. Okay, so that would be 60K will be something here. And the return, the rate of return is 35%, right? Remember that? So you can draw something like this. So this is 35% return, and this is the 60K you want to borrow, you want to use for their project. Okay, now take a look at the area of this blue rectangle. What is the area? So the area is the height times the width, okay? Which is the height is 35%, the width is 60K. What is that? It is the profit. Remember that? Okay, so which means the area, the size of this rectangle is the profit you earn from doing that project. And then what is the area of this black rectangle. The same, it is the height times the width. The height is 10%. The width is 60K. So what is that? That is the interest you want to pay back to the bank. All right, so we said if your profit can cover your payback, then which means that's a good project, right? So obviously, this blue rectangle, the area is much bigger than the black rectangle, which means the project A is something you can say yes to. Okay, so this is a way where you can compare your interest rate and the bank's interest rate, and to see if your rate of return is higher than that. Okay, then now let's imagine you have all the projects aligned on this chart. Okay, and they are ordered by their rate of return. So the highest rate of return goes the first, and the project B, lower rate of return, goes to the next, and then the C, and then the D. So they have the order of, they are ordered or prioritized by their rate of return from the highest to the lowest. Okay, and then you have this blue curve, which is the curve of interest. You want to interest rate you want to pay back to the bank. And so just by observation, the project A, project B, C, D, E, they all have their, profit covering the payback you want to pay to the bank, the interest you want to pay to the bank, because their area is much bigger, and this is how much bigger it is compared to what you need to pay back. Remember these two areas, right? So project B, yes, because the profit is more than how much you want to pay, and this is how much more. Okay, this is how much more, this is how much more. Okay, and the C is the same. This is how much more. It is over the how much you pay back to the bank, and the same to the D, same to the E. But be careful when you're looking at the project F. Okay, you want to borrow more than 600. Well, this is 600 million. Well, we use 600K, so we can use that as $1,000. Okay, so you want to borrow more than $600,000 from the bank. Then you need to pay, that is the interest rate you need to pay. And this is how much profit you can make. If you compare that with how much you need to pay to the bank, the area is almost the same, which means the little more you borrow from the bank couldn't cover or barely just cover the interest you need to pay to the bank. So that is the border or the bottom line where you need to say no to the project. Because if you cross that border, that means the money you need to pay back to the bank could not be recovered by the profit of that project. It's not a good deal. Okay, so you want to say no to project F, and of course you want to say no to project G, because the profit you earn from that project is even lower than the money you need to pay back to the bank. See, this area is lower than this blue line. Okay, so your cost is not going to be recovered by the payback, by the return. So this is another way where you can decide what is your maximum attractive rate of return. Okay, so your minimum attractive rate of return is the level of interest rate where the project can recover the cost. And based on this chart, we determine that, okay, 16% per year is gonna be that rate of return. So this is just one of the many ways you can determine your MARR. Okay, but the takeaway for you is the MARR is some bottom line, and you want to use that as the interest rate to calculate the cash flow, to convert the cash flow, but you want to know that's the bottom line, that's the lowest interest rate you can accept. So if you have higher interest rate than MARR, then of course your cash flow is gonna be healthier. Okay, whatever you calculate out is gonna be higher. But if you have lower interest rate than your MARR, it's a concern. So you always want to use MARR as the bottom line. So you want to use that to calculate, to convert the cash flows to the present, to the future, or to every year, and compare that with the zero. So the first method is called the present worth method. And this is very easy to understand. So the present worth method is all cash flows at various times are represented by their equivalent values at a point in time called the present. Here, the I% is MARR. So like what I said, you just want to draw the cash flow diagram and then convert all the cash flows back to the present and using the I% equals to MARR. And to see if the present worth, or we can say actually it's P0, if it's bigger or equal to 0. And at the MARR, which means you use MARR as the I% for the conversion. If it is bigger or equal to 0, then the project is acceptable. Okay? If not, you're gonna reject that proposal. So usually you're gonna have single cash flow at the end of the ends period. That's the first case. Okay, so it is easy. You just need to make this future cash flow, convert that back to the present time. Okay, so you want to see what is P0 and compare that with 0. And another case is you're gonna have cash flows every year. So you're gonna have annuities. Okay. Could be earning, could be spending. So you want to convert all of this back to present time, and still you want to calculate what is the P0 and compare that with 0. Okay, so this is very easy to understand. Now let's take a look at this example. Alright, so the example said, a piece of new equipment has been proposed by engineers to increase the productivity of a certain manual welding operation. The investment cost, so it's a capital cost, is $25,000. It means at the beginning, at present time, you need to pay $25,000 to buy the equipment. And the equipment will have a market value of $5,000 at the end of a study period of 5 years. So after 5 years, you can sell this equipment to the market and you get $5,000 back. Increased productivity attributable to the equipment will amount to $8,000 per year after extra operating costs have been subtracted from the revenue generated by the additional production. So what this means is, while you have some savings from the machine, you also need to have some operating costs and expenditures to use this machine. But the net saving, okay, the net saving is 8,000. Okay, so that is the net receiving of money in your company, and it happens every year, so it's kind of annuity. So first thing is and also the firm's MARR is given as 20%. Okay, so now how do you decide if this is a sound project or not? The first thing is we need to draw the cash flow diagram. Okay, so we draw it from the perspective of this company. From the company's perspective. So the cash flow diagram is you have 0, and it says the lifetime for this project is 5 years. So you have 1, 2, 3, 4, and 5. That's your timeline. So at the beginning, you need to pay 25,000. That's the expenditure, so it's going downward. And in the end of the 5th year, you can sell it as at 5,000. That's your receiving. And every year you can save a net receiving as 8,000. So that's 8,000 going upward. Okay, so the A is 8,000. And the I%, which is the MARR, is 20% per year. Okay, so that's the cash flow diagram. And now you want to convert everything back to the present to have the PW, the present worth. Actually, what you want to have is the P0. What is that? But you know it is PW, okay? It's better to write it this way. So PW, the present worth method, you want to calculate the PW, but actually it is the P0, right? But what is P0? Now the problem is multiple cash flows problem. Remember that? You need to determine how many parts of P0 you have. Okay? So how many parts? You have the first part, okay, and the second part of annuity from the annuity, and third, you have the P0 part of P0 from the future value of 5,000. So that's the 3 part. Okay, so P01, that's the first part. That is from the 25,000. And you know it is a present time value, so it's P. And the second part is from the annuity, which is 8,000 every year. And you know it is a type of annuity, right? And the third part is from the future value of 5,000. So that is a future cash flow. What's going on with my pen? Okay. All right. But you know you want to convert all the cash flows back to present. So you want to convert this to present. You want to convert this to present. You want to convert the future cash flow to present. That's your goal. So now let's do the conversion. So P01, it is already at present. So there's no interest rate going on. You don't have to convert anything. So 25,000 is 25,000. But it is the expenditure, so it's negative. So negative 25,000. That's the first part. And the P02, it's from the annuities, so it's to find P given A. Okay, and it's receiving, so it's positive. The equation to find P given A is A times a factor, which is P slash A. The I percent is MARR, right? You can just write it directly like that, and then N. So it's positive. A is 8,000. The factor is P slash A. MARR is 20%. N is 5. Okay, so now you need to check the table of I equals to 20%. You want to find P slash A. And the number of years is 5. So here is your factor. So it is positive 8,000 times 2.9906, which is positive 23,924.8. Okay, and next let's calculate P03, the third part. Still, it's a receiving of 5,000, so it's positive. And it's to find out present value given future value. So the equation is the F times a factor P slash F MARR N. So positive 5,000 times the factor is P slash F 20% and 5. It's positive, so let's give it a borderline here. You gotta find this factor in the table. So it's P slash F and 5 years, so this is your factor. And that is 0.4019. So the final result is 2,009.5. Okay, so now what is the P0? The P0 is the sum of P01 plus P02 plus P03. Okay? P01 is a negative number. It's 25,000. P02 is 23,924.8. And P03 is 2,000. Why it's so thick? Let me write it down here. So 2,009.5. Okay. And the final result is positive 934.3. So your PW is P0, which is a positive number 934.3. It is bigger than 0, obviously, which means this project is a sound one. Okay, so that is your conclusion. Make sense? Okay, so let me see. This is just a note I made on the whiteboard. Okay, it's the same as what we have written here, so don't worry about that. You can skip that side. And okay, let's do another example. Okay, because this is really very useful method, and I want to show you more examples so that you can better understand the logic. Okay, so here a retrofitted space heating system is being considered for a small office building. Okay, you want to install a new heating system. The system can be purchased and installed for 110,000. So that's the capital investment you want to pay for this new system. And it will save an estimated 300,000 kilowatt hours of electric power each year over a 6-year period. So the timeline is 6-year period. And every year you can save, by using the new heating system, save how much? Save 300,000 kilowatts. But how much is that? Don't worry. So 1 kilowatt hour is 10 cents. Okay? So if you want to know how much you save, from using the new heating system, that is per year. That is what? That is 300,000 kilowatts hours times 0.10. Okay. See, this is the cost estimating, or the estimating method we have learned. It's a unit method. Remember that? Although this is saving, it's the same. Okay. So how much you can save every year? It is 3,000. Okay. All right. So let's continue to read the statement. And the company uses a MARR of 15% per year. Okay, you see MARR is always given. Okay, in its economic evaluations of refurbished systems. The market value of the system will be 8,000 at the end of 6 years. Okay, and additional annual operating and maintenance expenses are negligible. Okay, so you want to use the PW method to determine whether the system should be installed, if you want to accept that or not. So the first thing is you want to draw the cash flow diagram first. So you draw it from the office building's perspective. From the office's perspective, actually. Okay, because you're the office, so you want to install it, so you need to spend this 110,000. That's gonna be your first cash flow. So 0, 1, 2, 3, 4, 5, 6. Your first cash flow is outgoing. 110,000. Okay, and every year you can save 3,000. Remember that? So that's your receiving. It's going upward. Okay, so A is 3,000. And in the end of the 6 years, you can sell that system. Market value is 8,000. That's another receiving at the end. So it's another 8,000. All right. And your I% is MARR, which is 15%. Okay. So that's your cash flows. And then the same thing, you want to convert all of them back to the present time. So actually your question is, what is the present worth? It equals to P0. But what is that? You have multiple cash flows. You need to determine how many parts you need to do. So how many parts? You have a present investment, the first part. You have the annuities, the second part. You have the market value, the receiving in the future, the third part. Okay, so you do the same thing. You have P01, which is from the 110,000. It is the present value, okay? And you also have the part 2, which is from the annuity, equals to 3,000, and it is annuity. Okay? And then you have the third part, which is from the 8,000 market value. It is a future value. Okay? And next, you just want to convert these 3 parts back to the present. Okay? So back to the present, back to the present, convert back to the present. So P01, it is already happened at the beginning, so you don't have to convert anything. So the amount stays the same, but it is a negative amount. Again, the negative doesn't mean it's lower than 0. It means it's an expenditure. Okay, and the P02 is to find out P given A. So the equation is A times P/A MARR N. And A is 3,000. P/A, it's 15%, right? N is 6. So just check this. So P/A, again, this table is for I equals to 15. Okay, you always find out the table first, and then find out the column and the row. Number of years, 6. So this is your factor. So it is 3,000 times that 3.7845. Which is positive 11,353.5. Okay, this is the receiving, so it's positive. And part 3 is positive. And the equation is to find out P given F. So it's F times a factor P/F MARR and N. So it's positive. F is 8,000. And the factor is P/F 15%, 6. So positive 8,000 times the factor is P/F. Rho is 6, so it's this. So it's 0.4323. It's positive what? 3,458.4. So now the P0 is the sum of these three parts. The first part is negative. Second part is positive. Third part is positive. Sorry, it's too thick. And the final result is 6,993.4. Okay, so the PW is P0 is 6,993.4, which is bigger than 0, which means this heating system should be installed. So you accept this proposal. Okay, so this problem is exactly the same as the previous one, except that at the first you need to calculate what is the annual saving. Okay, that's the only tricky part. But it's very real case, right? You're not always given all the values at the beginning. All right. And today we're going to learn something called bond value. Bond value is something that is actually, you can use the present worth value to help you determine if the bond is valuable or not, if you want to pay that much for that value on the bond. Okay, so this is a real case for the present worth method. Before that, I don't know if you have heard bond or if your parents have bought any bond, like a treasury bond from the United States or other country or even companies. Okay, so now let's see if
bonds are a common
video
investment.
about
However,
what is a
to many investors, they remain a mystery. So let's explore what a bond is and how it might benefit your investment portfolio. A bond is simply a loan given to a company or government by an investor. By issuing a bond, a company or government borrows money from investors,
A bond is
who in
simply a
return
loan
are
given
paid
to a
interest
company
on
or
the money they've
government by an
loaned.
investor.
Companies and
By
governments
issuing a
issue
bond,
bonds
a
frequently
company
to fund
or
new
government
projects
borrows
or
money from
ongoing
investors,
expenses.
who in
Some
return
investors
are
use
paid
bonds
interest
in
on the
hopes
money
of
they've
preserving
loaned.
the money they
Companies
have,
and
while
governments
also
issue
generating
bonds
additional
frequently to
income.
fund new projects
Bonds
or
are often
ongoing
viewed as a
expenses.
less risky
Some
alternative to
investors use
stocks
bonds
and
in
are
hopes of
sometimes
preserving the
used to
money they
diversify a
have, while
portfolio.
also generating
Consider this
additional
example.
income.
The city of
Bonds are
Fairview wants
often
to
viewed
build a
as a
new
less
baseball
risky
stadium,
alternative to
so it
stocks
decides
and
to
are
issue
sometimes
bonds
used
to
to
raise money.
diversify a
Each
portfolio.
bond is a loan for
Consider this example.
$1,000,
The city
which
of Fairview wants
promises
to build a
pay
new
back
baseball
in 10
stadium.
years.
So
to make
it
this loan
decides
more
to issue
attractive to
bonds to
investors,
raise money.
Fairview agrees
Each
to pay
bond
an
is a
annual
loan for
interest rate of
$1,000,
5%,
which
which in the
Fairview
bond world
promises
is
to pay
also known
back in
as a
10 years.
coupon rate.
To make this
An
loan more
investor buys the
attractive to
bond at
investors,
face value
Fairview
for
agrees to pay an
$1,000.
annual interest
Now,
rate of
let's fast
5%,
forward.
which in the
Each
bond
year,
world
the
is
city of
also known
Fairview
as a
pays the
coupon
investor
rate.
$50.
An investor buys the bond
These
at
regular
face
interest
value
rates
for
continue for the length of the
$1,000.
bond,
Now,
which
let's
is 10
fast
years.
forward.
Once
Each
the
year,
bond
the
reaches
city of
maturity,
Fairview pays the
the
investor
investor redeems
$50.
his bond, and
These
Fairview
regular
returns
interest
his
rates continue for the
$1,000
length of the
principal
bond,
investment.
which is
This
10
bond
years.
was a good
Once
deal
the
for
bond
both the
reaches
city
maturity,
and our
the
investor.
investor
Fairview
redeems
got
his
the money
bond,
it needed
and
to build the
Fairview
stadium.
returns his
The investor
$1,000
received regular
principal
interest
investment.
payments
This
and the
bond
return
was
of
a
the
good deal
original
for both the
investment.
city
Because
and
the
our
bond
investor.
offers regularly
Fairview got the
scheduled
money it
payments
needed to build
and
the
the return
stadium.
of invested
The investor
principal,
received
bonds are
regular interest
often viewed
payments
as a
and
more
the return of
predictable
the
and
original
stable form
investment.
of investing.
Because a bond
Compare
offers
regular
regularly
payments of a
scheduled
bond to
payments
the
and the return
experience
of
of owning owning a
invested
stock.
principal.
With
Bonds
stocks,
are often
profits and
viewed as a
losses
more
are driven by
predictable
market
and stable
forces
form of
and are
investing.
generally less
Compare
predictable.
regular payments of
Of
a
course,
bond
like
to the
any
experience of
investment,
owning a stock.
bonds are
With
not without
stocks,
risk.
profits and losses
One
are
risk
driven
that
by
bond
market
investors
forces
face
and are
is the
generally less
possibility that the
predictable.
issuer
Of
defaults
course,
on paying
like
back
any
the principal.
investment,
This is what is
bonds
known
are not
as
without
default
risk.
risk.
One
Typically,
risk that bond
bonds with
investors
higher
face
default
is
risk
the
also
possibility
come
that
with
the
higher
issuer
coupon
defaults
rates.
on paying back
The
the
amount of
principal.
risk
This
depends
is what is
mostly
known
on the
as
financial
default
stability
risk.
of the issuer.
Typically, bonds
For
with higher
example,
default
most
risk
governments
also
are
come with
generally
higher
considered
coupon rates.
stable issuers
The amount
and
of
issue
risk
bonds
depends
with a
mostly on the
relatively
financial
low coupon
stability
rate.
of the issuer.
Corporate bonds
For
typically
example,
represent
most
a greater
governments
risk
are
of
generally
default,
considered
as
stable
companies
issuers
can
and
and
issue
do go
bonds with a
bankrupt.
relatively low
That's why
coupon rate.
corporate bonds often
Corporate
offer a
bonds
higher
typically
coupon rate.
represent a greater
Several
risk of
credit
default.
rating agencies assign
Companies
rankings
can
to different
and do
bonds.
go bankrupt.
This can help bond
That's
investors
why
to
corporate
gauge the
bonds
financial
often
strength
offer
of
a
the bond
higher
issuer.
coupon rate.
These
Several
ratings
credit
agencies
rating
often
agencies
use
assign
different
rankings to
criteria for
different
measuring
bonds.
risk.
This
So,
can help bond
it's a good
investors
idea to
to
compare
gauge the
ratings when
financial strength
considering
of
a
the bond
particular
issuer.
bond.
These
And keep in
ratings
mind,
agencies
rating
often use
agencies
different
aren't always
criteria for
accurate,
measuring risk.
so be sure to research a bond
it's a good
and its
idea to
risks
compare
thoroughly
ratings when
before
considering a
investing.
particular bond.
Another
But
risk
keep
to
in mind,
consider is interest
rating
rate
agencies
risk.
aren't always
This
accurate.
is the risk that
So be
interest
sure to
rates will
research a
go up,
bond and
and
its
any
risks
bonds you
thoroughly
own
before
will be worth
investing.
less if sold before
Another
the
risk
maturity
to
date.
consider is interest rate
After all,
risk.
when interest rates
This is the
rise,
risk that
more
interest rates will
investors
go up,
allocate their
and
money
any
into the
bonds you
new
own
higher
will be
interest
worth
rate
less
bonds.
if sold
If you
before the
wanted to
maturity
load
date.
a low interest rate
After all,
bond
when
to take
interest
advantage
rates
of these new
rise,
rates,
more
you have to
investors
sell your
allocate
bond
their
at a
money into the
discount
new
to make it a
higher interest
worthwhile
rate
purchase
bonds.
for another
If you
investor.
wanted to unload a
Capital
low interest rate
preservation
bond
and
to take
income
advantage of
generation
these
are
new
just two
rates,
ways
you would have to
bonds
sell
might
your
be
bond
part
at
of
a
a diversified
discount to make it a
portfolio.
worthwhile
Many
purchase for
investors
another
use a
investor.
mix of stocks and
Capital
bonds to
preservation
pursue their
and income
investment goals.
generation are
And
just two
because
ways
bonds move
bonds
differently
might
from
be part of a
stocks, they
diversified
can help
portfolio.
increase or
Many
protect
investors
portfolio
use a mix
returns.
of stocks and
Keep in
bonds
mind
to
that this
pursue their
discussion
investment
showed you
goals.
one
And because
simplified way
bonds
that
move
investors
differently from
might use
stocks,
bonds,
they can
and
help
only a few of
increase
the
or
risks to
protect
consider.
portfolio
Like all
returns.
investments,
Keep in mind that
bonds
this
are
discussion
complex
showed you
and
one
have a
simplified
variety of
way that
uses and
investors
risks.
might use
Before you
bonds,
invest
and
in
only a
bonds,
few of the
it's
risks to
important that you
consider.
invest
Like
in your
all
own
investments,
financial education.
bonds are complex and have a variety of uses and risks. Before you invest in bonds, it's important that you invest in your own financial education.
All right, so it sounds very interesting, right? So bond is something you can invest your money instead of saving them in the saving account or buying some stocks, okay? And now let's go back to our PowerPoint to see what exactly a bond is. Okay, so here is just an example of a bond which is issued by the United States of America. Okay, and you can see that there is a bond coupon rate. It's 1/8%, and the due date, you see, that is the November 15th, 1994, and the issue date is almost 20 years ago. Okay, and so that's some information you have on the bond coupon, and also here is the value of that coupon. Okay, so here are some terminologies. The first thing is the face value. So the face value is this. This is called Z. That's the value on the coupon. Okay, on the bond coupon you buy. You will pay less than this face value to buy this piece of paper. It's kind of a certificate to say, hey, you paid for this piece of paper, and then on the paper it will say how you get repaid. Okay, so the first term is Z, the face or the value of the coupon. And another term is C, redemption or disposal price. Usually it equals to the Z. Okay, so the redemption is the company or the country who issued this bond will say, okay, after the bond is retired, maybe it's 20 years. So after 20 years, I will pay a lump sum back to you, okay, a single amount to you. How much is that amount? That is called C, the redemption, and usually it is equal to the face value of this coupon. So your coupon, one piece of paper is 10,000 in this case, and after 20 years, you're gonna get that 10,000 back. So that's the redemption. And another term is R. R is bond rate per interest period. Okay, but usually it is given as a nominal annual interest rate. Okay, remember we have learned that nominal annual interest rate in the last class. Okay, you will use that here. So bond rate it is the interest rate you use for per interest period to calculate how much interest you get from that bank or that country issuer. Okay, so except for the lump sum of C, the redemption you're gonna get in the end of the 20 years, every year or every month, it depends on how the calculation of interest goes, you can get some interest. That's just another attraction, another incentive for you to buy this coupon. Okay, so you got interest every interest period. And the interest amount is calculated by using this R. Okay, and another term is N. N is number of periods before redemption. Okay, it's called number of periods, which means it's not necessarily to be a year. It could be a quarter. It could be a month. It could be a day. It depends on how long the company or the issuer calculate their interest to you. Okay, so it's number of interest periods. And I is called bond yield rate per period. Actually, the I is something you can see as your personal MARR. Okay, so your personal MARR. So that is the yield, that is the interest rate you want. Okay, so as a customer, you buy this coupon, but you have your bottom line in your heart. You know that what is the bottom interest rate you want. That interest rate could be the interest rate in the saving account in the bank, right? Because if you use the money to buy this coupon, you don't have the money saving in the bank. But the opportunity cost is the interest you can get from the bank. So the interest rate provided by that saving account is gonna be your MARR. You're gonna say, okay, if you want me to buy the coupon, you need to give me the interest higher than what I can get from the bank. Make sense? So this I is the yield rate. That's what you want that's what you want from the investment. It's your personal MARR. Okay, so that is different than the bond rate. So bond rate R is decided not by you. It's decided by the bond issuer. Okay, so that's the difference. And the last term is VN. That is the value of the bond and interest periods prior to redemption. So the VN is also something you can see as the price you want to pay. So imagine for the face value of 10,000 coupon, the less you pay, the more you can get. Does it make sense? You always want to pay less, right? So the chance for you to earn a lot is higher. So you want to pay less, but there is a maximum line, okay? The issuer is not silly. They want you to pay more. But there is a line there, which is the maximum price you can afford, okay? So that maximum price is something we call VN here, or the price you can afford. So if you pay more than that maximum price, which means the chance for you to lose money is high. But if you pay lower than that maximum amount of money, the price, which means the chance you can earn some money is high. Okay, so you always have a maximum price you can pay. And that price is called VN. Okay, so that's some terminology we use to describe the coupon, the bond value. And so based on the description in the video, buying a bond coupon, what you can get is two parts of payments, or two types of payments from the issuer. The one is a series of periodic interest payments until the bond is retired. Because it's periodic and it's the same amount every period, so it sounds like annuity, right? And another payment is the final C, the redemption you can get when the bond is retired. So it's a future value. So if you draw this, a generic cash flow diagram for a coupon, it looks like this. So at the beginning, you pay the price. Okay, that's the price you pay. And we call it VN. And then every compounding period, it could be a quarter, okay, until it's retired. You don't know which year because it's generic graph. So every compounding period, you got some interest, okay, so that is A. And then in the end, you can get additional lump sum, which is called the C, the redemption, okay? And usually the C equals to the face value of the coupon. So this is a generic cash flow diagram for the bond issue, the bond problem. And what you want to know is what is the price or how much you can afford as a maximum to buy this coupon, okay? So to know that, you want to convert everything back to the present, the PW. So what is the PW? And that is your price. Okay, so what you want to know from this bond problem is for a desired yield rate, remember that your personal MARR is your interest rate to use. So at a desired yield rate, how much would you be willing to pay for the bond? That's the question. And actually, it's to convert everything to the present worth. Okay, so the present worth of the bond is the present worth of all these payments, which can be calculated by this equation. Okay, so either you can draw this cash flow diagram and to convert it from different parts of cash flow, you remember that, by yourself, or you can just use this equation. Okay, but to use this equation, you have to know what is C, what is the I%, what is N, what is R, what is Z. Okay, you got to know all of these variables. And there is something very tricky in this, okay? Because the coupon rate, the R and the I, they usually will be given as a nominal interest rate. So it's given as nominal rate, okay? But in the equation, they are already interest rate per period, okay? So in the equation, the I% should be some percent per period. The R will also be some percent per period. So it's given in the problem as a nominal rate, but in the equation, you want to use it as interest rate per period. So you have to convert the nominal rate to some rate per period. That is why I said it's tricky. And another one is the N, okay? Because usually the bond will tell you how many years it's gonna be retired. But because it's compounded not yearly, maybe quarterly. So you have to know the number of periods instead of number of years. Okay, so it's number of periods, not number of years. Of course, if it's compounded yearly, it's number of years. So not necessarily. Did I spell it correct? Necessarily. So it's not necessarily to be number of years. It could be number of quarters or number of months. Could be. Okay, so it depends on how long the interest is calculated. Okay. Okay, so to convert this and to get this, you all need to know how often the interest is calculated by the issuer in a year. Okay, so if it's compounded semi-annually, so in a year it's compounded twice. If it's compounded quarterly, in a year it's compounded 4 times. We have discussed this before, okay? But here we want to just emphasize it again. That's the tricky part. All right, now let's see an example. Okay, so the question is to find out the PW or the VN of a 10-year bond. Okay, 10-year bond is the lifetime of the bond. Okay, but not necessarily you have 10-year periods. Okay, it depends on how it's compounded. So let's continue. It's paying 6% per year nominal rate. See, that's a nominal rate. So you don't want to use 6% directly. It's compounded semi-annually. Semi-annually means what? Means it's compounded OUNDED 2 times a year. Okay, when I say compounded, it's equal to when I say the interest is calculated. Okay, that's the same meaning. So if it's semi-annually, which means every year it's compounded twice. All right. So you know that the bond rate, the R, will be 6% over 2. So every period, the R actually is 3%. That's the bond rate, the real bond rate. Okay, so you can answer the question of this. R is 6% over 2, which is 3%. And let's continue. That is redeemable at face value. So redeemable at the face value, which means your Z is your C. If bought by a purchaser to yield 10% per year nominal rate, okay, yield rate or your personal MARR, you know 10% is your nominal rate, compounded semi-annually. So every year you are gonna, calculate your MARR, your interest twice. So your yield rate is gonna be 10% over 2 because every year you wanna calculate twice, right? So it is 5%. You never use the nominal rate directly in the calculation. You always need to convert that into the interest rate per periods. Okay? And in this case, one period is 1/2 year. So you can also answer this question. Your yield rate is actually per period, yield rate is 10% over 2, which is 5%. Okay? And the face value of the bond is 1,000. So the Z is 1,000. And it said that the redemption is going to be the same as the face value. So the C is also 1,000. Okay? And so the last value you want to know is N, number of periods. So the N is not 10 years because every year you need to compound or calculate the interest twice. So it's going to be 10 times 2. It's 20. Okay? So once you have a bond problem, you always want to find out these values like this. And the tricky part is you need to know how often the interest is calculated a year, okay? So that you can convert your R, your I to the interest per period. So the 3% is 3% per half year. And 5% is 5% per half year. Okay? And the N is 20 half years. Okay, makes sense? And then from here, you can use the equation directly to calculate the VN for this coupon. So now let's use it for this example. So Stan Moneymaker has the opportunity to purchase a certain US Treasury bond, and the bond is gonna be matured in 5 years. And it has a face value. So the 5 years is how long the bond is gonna be retired. Okay, after 5 years, it's gonna be retired, and the face value of the bond is 10,000. So you can write it here. The Z is 10,000. This means that Stan will receive 10,000 cash when the bond's maturity date is reached, which means the redemption is the same as the Z. So C is the same as the Z is 10,000. Okay. The bond stipulates a fixed nominal interest rate. See that? Nominal interest rate? So you're going to be careful. You're not going to use the 8% directly. You have to convert that to some interest per period. Okay? But interest payments are made to the bondholder every 3 months. Okay, so every 3 months you are going to receive interest, which means the interest is calculated every 3 months. Okay, so from that, you know interest is calculated or compounded, the same meaning, every 3 months. Okay, so every year it is calculated how many times? 4 times. Okay, that's something you know. So this 8% interest rate the company, the issuer will pay you, that is the nominal rate. And your real bond rate, R, the interest you get back from that issuer, is actually 8% over what? Over 4, because every year it's compounded 4 times. So the bond rate is 2% per 3 months. Okay, or per quarter. Yeah. And what else? Yeah, so it's given already, but I want you to still know how do you convert that. So each payment amount will be 2% of the face value. Okay, so that annuity is gonna be R times Z, which is 2% times 10,000. So every quarter you will get 200 as your interest. Okay, and Stan would like to earn 12% nominal interest per year on his investment, and also it's compounded quarterly. So the 12% personal MAR is a nominal rate. So you want to convert that to MAR per 3 months as well. So your yield interest rate will be actually 12% over 4. So it's gonna be 3% per 3 months. Okay, so the I is gonna be your yield rate, the interest rate you want at the bottom line. Okay. So the question is, what is the bond price you want to pay? Okay, so to draw the diagram or to use the equation, you also need to know what is N, number of compounding period. Is it 10? Oh, is it 5? No, because every year you need to compound it or calculate interest 4 times. So it's gonna be 5 times 4. Okay, 5 is years of the bond, and the 4 is what? Is this. So N is 20. Okay, so now let's use the equation. The equation is, okay, let's just copy this. The equation is Vn is C times P slash F I% N plus RZ times a factor P slash A I% N. Okay, C is 10,000. The factor is P slash F, I is 3%, N is 20, R is 2% per 3 months, Z is 10,000. Factor P slash A, I is 3%, N is 20. Okay, so that is the value you want to use. So 10,000 times, you want to check the table of I equals to 3%. So that is the table. And you want to find out P slash F. And N is 20. So this is your factor. That is 0.5537. Another part of the equation is 2% times 10,000, that's gonna be 200, times the factor P slash A, n is 20, so that is the factor. It's 14,8775. So the final is 8,512.5. So that is the maximum price you want to pay for this 10,000 bond coupon. Okay. So this is an example. And if you look at the textbook, I have some change over there. Okay. It's just to make sure you have a table to use in the Appendix C. If you use the textbook's example, you won't be able to find a table to use. So I just changed those values in this example. But the logic is exactly the same. Okay, so that's it for today. And I hope the bond problem is helpful for you when you want to make your personal investment. Okay, and you got a equation to tell you what